Hello pre-calc honors students, here are the law of cosines, and our objective is to use the law of cosines to find unknown parts of a triangle. Let's start off with a proof because we did so much with coordinate geometry proofs from before. If we look at a triangle ABC, it's going to have sides, little a here, little b over here, and little c over here, opposite this angle C like this. And the trick is to get a coordinate for this point. If we put angle C at the origin, and side B, side A here, segment CB along the x-axis, then the y-coordinate will be 0 and the x-coordinate is A. Now it's a little trickier getting this coordinate out in space here in the middle of the first quadrant. So let's take a look at this triangle, just this right triangle now that I've made, and come up with different parts of it so we can come up with this coordinate. It's got this side B and this angle C, but we don't know either of these two sides yet. Remember, this A is all the way along here. So, let's call this just X and Y for now, and use our SOHCAHTOA. The sine of angle C equals opposite side over hypotenuse, however b, and the cosine of angle C will equal adjacent side x over hypotenuse. So therefore, we come up with the coordinates y equals b sine C and x equals b cosine C. So that's what we can put in for the coordinates here. B cosine of C and b sine of C for the coordinates of this point. Now we can use the distance formula from A to B to figure out what that length C should be. So C is the distance from A to B, and that should equal the square root of the difference in the x-coordinate, so that's b cosine C minus A, all that quantity squared, plus the difference in the y-coordinates, that's b sine C minus 0 quantity squared. So we square both sides, and we get c squared equals, and that'll get rid of the big square root over here. And then we start expanding this, so it's going to be b squared cosine squared C minus 2ab cosine C plus a squared plus, and the minus 0 just disappears, so we get b squared sine squared C. And notice we have a b squared in common to these two terms, so I'm going to factor out the cosine squared C plus the sine squared C. That's coming from these two terms here. Plus a squared, and let's not forget the minus 2ab cosine of angle C. Well, cosine squared C plus sine squared C is just 1. So we get c squared equals b squared plus a squared minus 2ab cosine of angle C. Or maybe you remember it as c squared equals a squared plus b squared, looking a lot like the Pythagorean theorem, but then minus this sort of correction factor, minus 2ab cosine C. Don't forget that it's minus. In our case over here, when C is acute, you're going to actually make it less than what you'd expect from a right triangle with A and B meeting at a right angle. And when you make C larger than 90 degrees, then the cosine of something in the second quadrant is going to be negative. That'll make this a minus minus, and it'll make it actually bigger than what you expect in the right triangle. Now in English, this means any side squared equals the sum of the squares of the other two sides. And that's the Pythagorean theorem. But then minus twice the product of those two sides times the cosine of the angle between these two sides. So let's try it with this. Q squared then, that's any side squared equals the sum of the squares of the other two sides. So it's r squared plus b squared minus twice the product of the other two sides, r times b, times the cosine of the angle between them, the cosine of q. Okay, let's try this example. Suppose that two sides of a triangle of lengths 3 and 7, and that the angle between them measures 130 degrees. Find the length of the third side. So we've got 3 centimeters and 7 centimeters, and that looks like about 130 degrees. And a fairly decent sketch then can give you a good estimate. But we're going to be well over 7. I'm thinking somewhere in the 8 and 9 range. So let's call this unknown side x. So x squared should equal 3 squared plus 7 squared minus twice the product of the other two sides times the cosine of the angle between, cosine 130. And so you get x squared, we put that in the calculator, and you get 85.0 approximately. Don't forget though to take the square root, and so we get approximately 9.22 centimeters. And that checks out with our answer there. Okay, in example 2, the lengths of the sides of a triangle are 5, 10, and 12. Solve the triangle. So that means find all the other three sides. 5, 10, and 12. Well, 12 is the longest side, and then we got a side 10, then we got a side 5. I suspect it's obtuse, but I'm not sure. But the thing is, that's exactly it. I don't know if it's an acute triangle or an obtuse triangle. I don't know if all the angles in it are 90 degrees or less, or maybe there's some obtuse in there. So this is the one issue you have to consider when you're looking at general triangles. When you're solving right triangles, you can just assume you got 190 and the other two are acute angles. But in this case, we could have an obtuse angle in here. And if we were going to have an obtuse angle, it would be here, opposite the 12. So let's call these angles alpha, beta, and theta. Just to play with our Greek letters here. Alpha, beta, is where our word alphabet comes from, and theta. These are very commonly used. Occasionally you might find me using a gamma. Some Greek letters you get used to looking at. So I'm actually going to find alpha first because it has the potential to be an obtuse angle because it's opposite the largest side. If there is an obtuse angle in a triangle, there can only be one, and it would be opposite the largest side. So I'm going to find this with a variation on the law of cosines. Well, let's do it both ways, and then I'll teach you a little mini formula. A lot of kids just set up this way. They say 12 squared equals 5 squared plus 10 squared minus twice 5 times 10 times the cosine of angle alpha. I'm actually going to go through this because there's a common mistake that happens here. 144 equals 25 plus 100 minus 100 times the cosine of alpha. And a lot of times kids mistakenly subtract these. No. It's 125 minus 100 cosine alpha. You have to subtract the 125 from both sides first. Don't do this 125 minus 100 equals 25 mistake. Ouch. We'll take off all points for doing that. You got to know your order of operations here. Subtract 125 from both sides, and you get then 19 equals negative 100 cosine of alpha. Divide both sides by negative 100, we get negative 0.19 equals cosine alpha. And now you can use inverse cosine. And this is where the law of cosines is better than the law of sines. In fact, that doesn't have this ambiguity. If you take the inverse cosine of negative 0.19, you know you've got an acute angle. And that's where we get the alpha of 101.0 degrees. Now at this point, we could use law of cosines to find the other two angles, or even to find one more angle. But I find it easier to use the law of sines. It's easier to set up. So now we use law of sines, and let's find unknown side beta. The sine of beta is to the side opposite beta, which is 5, is equal to the sine of angle alpha, which we just figured out, 101.0 degrees, and the side opposite alpha is 12. I find this easier than setting up the whole law of cosines again. 5 sine 101.0 degrees over 12. You get the sine of beta equals, let's pause a bit for a sine of beta equals, well, keep it in your calculator because you're just going to go ahead and do beta then equals the inverse sine of the answer you got from up here, and you get 24.1 degrees. Now, for the third angle, use the fact that the sum equals 180. And that's going to be easier than either the law of cosines or the law of sines. And so alpha plus beta plus theta must equal 180 degrees. So theta will equal 180 minus the sum of our other two angles that we found. So we get 180 minus the sum of the 101 degrees plus the 24.1 degrees, and you get our angle theta is 54.9 degrees. So there are the three angles. And another thing to check then is the biggest angle opposite the biggest side? Yes. The 101 is opposite the 12. Is the smallest angle opposite the smallest side? Yes, 24.1 is opposite the small side, 5. That's what we get for beta. So beta. Okay, in our third example, in the diagram below, AB equals 5, BD equals 2, DC equals 4, CA equals 7. We're trying to find this AD right here. So unfortunately, we only have two sides of this triangle ABD. But we can get this angle by using the law of cosines over here. And this is where I'm going to interject, and let's just back up a page, that you're used to the law of cosines looking like this. C squared equals A squared plus B squared minus 2AB cosine of angle C. Well, I put to you that you can solve this for cosine of angle C by putting these on the other side and divide by negative 2AB. And if I want to divide by positive 2AB, then it's going to be A squared plus B squared minus C squared over 2AB. So the cosine of angle B would be A squared plus C squared minus B squared over 2AC. And the cosine of angle A would be B squared plus C squared minus A squared over 2BC. Some kids prefer to memorize law of cosines in this format as well, because it's easier for when you're solving for an unknown angle. And that comes up in this problem right here. Let's try and find this angle B by using this. The cosine of B should equal, and now remember, I'm going to focus on this blue triangle first like this, to say, and this side is 6 now, 5 squared plus 6 squared minus 7 squared all over twice 5 times 6. So we get that's equal to 25 and 36 minus 49 all over 60. Which ends up being 61 minus 49 over 60, which is 12 over 60, which is exactly 1/5 or 0.2. Now we can actually find angle B, but let's think ahead here. We're actually going to find this side, this unknown side x, by looking at this red triangle now, the one in here like this, which basically uses this same angle B again, but now it's got sides 5 and 2 and x. And we use the law of cosines like this. X squared equals 5 squared plus 2 squared minus twice 5 times 2 times the cosine of angle B. And I'm actually going to replace all of cosine B with 0.2. So I avoid having to actually use inverse cosine, come up with the angle, only to take cosine again to get right back to it. So x squared equals 25 and 4 minus 20 times 0.2, or 29 minus 4. X squared equals 25, so x equals 5. So that's our unknown length AD. Now I want to wrap up this section by looking at some procedures that I alluded to in that one problem where we had 3 sides. These are 3-step procedures for all 4 kinds of givens in solving a general triangle. So when we have side, 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 this is the scenario where you basically have 3 sides of a triangle. And where do you start? Well, we're going to use the law of cosines to find an unknown angle. To find the biggest angle. How do you know where that is? Well, it's going to be opposite the biggest side. Now, the nice thing about law of cosines and find an unknown angle is it'll tell you if it's acute or obtuse in the equation itself. So now we can use law of sines to find the second angle, and it will be acute because we took the precaution of finding the biggest angle in step 1, because we got our biggest angle up here, and the smaller angles have to be acute. And then you can just use sum equals 180 to find the third angle. Now, in side angle side, it's the same tools, but used to find different things. We use the law of cosines, because now we've got the angle between two sides. So you can use the law of cosines to find this third side. Now we can use the law of sines again. But I want to make sure law of sines in finding an unknown angle can be ambiguous. But if I know it's not the possible acute angle, so what I'm going to do is use law of sines to find the smaller of the remaining angles. How do I know which one's smaller? I'd go for the one that's off the smaller side. So in my little sketch here, I'd go for this one. Not this one, because that might be obtuse, but this one is opposite the smaller side, smaller than this largest side, so it couldn't possibly be the obtuse angle. It will be acute. So these little precautions can help you avoid some of the issues with using law of sines to find an unknown angle. And then finally, of course, we can use sum equals 180 again to find the third angle. Now, this scenario is probably the easiest of three because you've got two of the angles already. So you actually start with using sum equals 180 to find the third angle. Now that you've got the third angle, you don't have any of those possible ambiguous cases. You can use law of sines to find the second side, and then law of sines again to find the third side. This takes us to our ambiguous case, the ambiguous or obnoxious case. Because you could possibly get 0, 1, or 2 answers. 0, 1, or 2 answers. And keep that in mind as you go through. Because you have to start with the law of sines to find the second angle. And this is where you have to consider that you might have 0, 1, or 2 answers as a result of doing this. Then you can use sum equals 180 to find the third angle. And again, you might have 2 answers there. And then you can use the law of sines to find the third side. Again, there might be 2 answers. Okay? That should wrap it up. Flange out.